Hi, algebra class. Welcome to our first flipped lesson. We're going to talk today about solving one-step equations. While you're in the comfort of your home or on the bus or wherever you are, I'm here working my heart out teaching you something. We're going to start by talking about a simple balance. If one side is heavier than the other, that side goes down. Obviously the opposite. But if they are equal, they stay perfectly in balance. If I had something like a pen on one side and the same kind of pen on the other, it would be balanced or equal. Now, if I do something to one side and I don't do it to the other, then it suddenly becomes unbalanced. But if I do the same thing to both sides, it should stay equal. If I take, for instance, the pen off one side and I take the pen off the other, then it will stay equal again. Okay, that's just a simple little analogy, but I hope it helps you as we talk about equations. Let's write a simple equation out here. 2 equals 2. Is it balanced? Yeah, you bet it is. Same thing on both sides. So that's the kind of thing that's going to stay balanced. If I wrote x plus 2, let me just add something here. Let me change it a little bit. Maybe I'll make this 5. So if I wrote x plus 2 equals 5, if you imagine that little balance or scale again, this side is equal in weight with this side. So if our strategy is to find out what the variable equals, we're trying to get everything that's with the variable to the other side, and then it will simply say x equals something. Does that make sense? These are like the classic problems of algebra, solving for a variable. So you got to have a solid foundation in this for us to go on. Tomorrow we'll do some examples. I'll walk around and make sure you guys understand this because this is a real foundational point for algebra. So here's what we have to think about. Each operation has kind of what we call an opposite operation. I think of it as like the reverse of it. So addition, what's the opposite operation? Did you answer? I'm waiting. Oh, just kidding. It's subtraction. And subtraction obviously would be addition. Multiplication would be, the opposite operation would be division. And division obviously would be multiplication, okay? Let's just work with those four right now. So what's with the x that we want to get rid of? It is an addition of 2. The way that we get rid of that 2 is we think, what's the opposite operation, which is going to be subtraction. And so if we subtract 2 from this side and we subtract 2 from this side, do you see, since we're doing the same thing on both sides, it remains in balance. The handy thing about subtracting 2 is if you add 2 and you subtract 2, this is all going to go away. And we'll be left with x, is what we wanted in the first place. And then you know how to do 5 minus 2, so x equals 3. Does that make sense? So we do the same thing to both sides. One ends up simplifying the side with the variable, and the other side gives us an answer. Now the cool thing about these problems is you'll always know that you were right or not. Remember, the original problem was x plus 2 equals 5. You should never have to come into class, wait for me to give you the answer and correct. You should know whether you're correct already. Because once you solve it here, simply plug that in for x. And if 3 plus 2 really equals 5, then you can't get it wrong. If it doesn't equal 5, you did something wrong, so you need to go back and stick to it. Okay? All right, very simple example. Let's do another one. What if we had 2x equals 8? First we think to ourselves, what's with the x that we want to get rid of? It is a multiplication of 2. Does that make sense? So how do we undo a multiplication? We do a division. And we have to do it to the other side as well. So 2 divided by 2 and then 8 divided by 2 keeps it all in balance. The nice thing about 2 divided by 2 again is, you know, the same thing over the same thing is always 1. And 1 times x is just simply x. So it's like we can just pretend that's not there. So it's going to turn out to be x equals 8 divided by 2 is 4. Again, check yourself. Make sure it's right. Stick the 4 in the original problem for x. 2 times 4, does it really equal 8? Yes, it does, so you're good. As we get more and more used to this, I will probably use a little shorthand. And ever since I was in 9th grade, and I took algebra in 9th grade, I've always just seen these problems in my head kind of doing a certain thing. And I tend to write it that way, but I want you to know it's just a shorthand. If you don't like doing it that way, you don't have to. I want to give you the option. But I want to explain how you're going to see it on the board sometimes. So like that first problem, it was it x plus 2 equals 5? I know what we're really doing is we're subtracting 2 and subtracting 2. I kind of get tired of writing all that. And I've always just seen this in my head because really it's kind of what's happening. Is I always think to myself, what's the opposite thing of addition of 2? It's a subtraction of 2. So I kind of circle that and I just see it going to the other side and then you subtract 2. Now remember what we really did was we subtracted 2 here and we subtracted 2 there. But I kind of just think of this thing when it moves to the other side of the equal sign turning into the opposite operation, and then it just kind of goes away. I just think of it as moving over and going away. So x equals 5 minus 2, x equals 3, which is what we had in the first place. Let me show you how I see the multiplication one. 2x equals 8. I know what we did was we divided by 2 and we divided by 2, right? But I just kind of see it as this 2, it was being multiplied. Now it goes over and it divides the 8 by 2. So then this left side goes away. And x equals 4. So again, don't let it confuse you. It's kind of how I just see the numbers moving. Maybe it's just a symptom of an addled mind. So you can use whatever way you, and especially at the beginning, if you want to write it on both sides and keep everything balanced, that's safer probably, and it's a good way to do it. I just want you to understand that sometimes I'll be doing something a little different. Let me show you one problem that sometimes people mess up, and I just want to point out a common mistake here. Let's say we had negative 2 times x equals 6. Well, sometimes what happens is when people think, oh, well, how do I get rid of the negative 2 from the x? Well, it is negative, so I'm going to add 2. That would be a mistake. You have to think to yourself, what is sticking this thing to the x? Well, it's being multiplied by x. The operation here is multiplication. The operation is not subtraction. So therefore, when we move this to the other side, we're trying to undo the multiplication. We're not changing the sign. So when that comes to the other side and we divide by negative 2, that's going to get rid of the multiplication. Okay? Or to do it in the longer form, we're going to divide by negative 2 over here, and we're going to divide by negative 2 over here. Negative 2 over negative 2, again, turns into a 1 and kind of goes away. But we don't want to mess with the sign. In one like this, let's say it was negative 6 plus x equals 7. We're undoing this addition. We're not undoing the negative sign. So when we move that to the other side, we're undoing this. So instead of addition, we're going to do subtraction, and we're going to keep it negative 6, which I know turns into plus a positive 6. So think about what the operation is that's going with the x. not just any sign that you see and changing that. That's the only mistake that I see people making sometimes. So to sum up, whenever they give you a problem, x divided by 2 equals 10. Think to yourself, what is the operation that's kind of, I call it sticking it to x, but you know, the operation that's doing something so that x is not by itself. In this case, it's division. It's x divided by 2 equals 10. So we think to ourselves, what's the opposite operation? Well, it's going to be multiplication. And then I would think, okay, I move that over here, and instead of dividing, I'm going to multiply by 2, x equals 20. And then lastly, I want you to check yourself. Take the 20, put it in there. 20 divided by 2 really does equal our original thing of 10. Okay, I hope that makes sense. I'll see you tomorrow. We'll practice this a little bit and go back to doing whatever you were doing. Okay.